right, so we're in section 1.2. Let's get started, guys. And I'm going to call it Foundations. And I'm not going to go through the PowerPoint, but I'm going to grab some pictures from the PowerPoint.
This goes in this sheet.
I'll tell you when we get to the parts that we need to put on that sheet. So, yes. Guys, let's stop talking. Yes, I'm sorry? So the first part where you're going to write in the definition. This part you don't need to necessarily write down. I just want to give you some background as to what we're doing here. So we're like we said last week, we're start studying actual geometry. What we're studying in this class is called Euclidean Geometry, and it was developed by a Greek mathematician by the name of Euclid at 300 BC. And Euclid wrote a book called The Elements, or several books called The Elements, and it was really the first time that a mathematician had written a book where the math was based on starting with a few basic ideas and building on those ideas using logic. So part of what we do in geometry is we learn about the shapes and how they all work together, but we also learn logic because geometry is really the first time that anyone did that with math. So we're kind of retracing a little bit what Euclid did, where we're learning logic and learning how to use logic to make connections in math. Euclidean geometry was the only kind of geometry that we knew until the 19th century, and then we figured out that there are other kinds of geometry possible. And the nice thing about geometry is it's based on we'll talk about what an axiom is in just a few minutes, but we start with a few basic ideas, and then we build on those using logic. All right. So our first three terms that we're going to put on our vocabulary sheet are our undefined terms. So in the facts or characteristics in three of your boxes, you should write undefined term because it's important that it's undefined. In three boxes for the facts and characteristics, you should write undefined term. And then we'll get to our undefined terms right now. So our first undefined term is a point. So the reason we have undefined terms is we have to start somewhere. We can't lift ourselves up, to use an old phrase, we can't lift ourselves up by our bootstraps. We can't pick ourselves up that way. So we have to start somewhere. We have to build some kind of little ladder to start climbing. Our undefined terms are those little ladders. Yes? Undefined terms should go in the facts and characteristics for three different boxes. So for so two on the front and one on the back. In the facts and characteristics, it should say undefined term. So our first term is a point. So that should go in the middle of your first box. Point. That's your term. It's undefined, so it doesn't have a technical definition. There's no definition. That's what undefined means. We have to start somewhere. So we come up with this idea of this thing called a point. So they say for an undefined term, the reason we call it undefined is it's not defined, but it's explained. It's an idea that we have, but we can't come up with a definition for it. So the other important characteristics. So point has no technical definition. Definition in your own words. You could come up with something in your own words in just a second. Point, important fact or characteristic, has no size. Think of the tiniest little speck of dust, and a point is even smaller. We usually show a point as a dot, and we name it with a capital letter. So this would be point B. So important characteristics or facts, it's undefined, doesn't have any size. We show it with a dot and we name it with a capital letter. An example, the way that we think of a point is something really, really tiny. So they give the example of the tip of a pencil, really, really sharp pencil. The tip of that pencil we think of as a point. You could come up with your own examples. What would be a non-example of a point? Something the size of a car, maybe. We think of. Now, if we're looking at a map from outer space, a car might be a point. But if we're looking at a car in the parking lot, we don't think of a car as a point. Outer space isn't a point. That's a non-example. So that's our first undefined term, is a point. Undefined, has no size, we show it as a dot, and we name it with a capital letter. So those are our important facts or characters. All right, our next undefined term is a line. So that's going to be your term. In your middle there, important factor characteristic, it's undefined. It doesn't have a technical definition. Another important factor characteristic, it has no thickness. So it's perfectly thin. It's perfectly straight and goes forever in both directions. It takes 2 points to make a line. So if you want to draw it for your picture, there are my 2 points on a line. And then we would connect those with something that went on forever in both directions. And to show that it goes on in both directions, we show little arrows on both sides. So that could be your picture. We name it, another important factor characteristic, we name it by 2 points on the line with a double-headed arrow over the letters. So we would say, and that's what this says down here. I'll write it there. This is line AB. So the 2 arrows tell us that goes on forever. So this is line AB. Sometimes you'll see a lowercase letter next to the line like this. You could also call it line L. But only if they put the lowercase letter next to the line. Most usually will say line AB. So all of these are important facts or characteristics. Doesn't have a technical definition because it's undefined. So what would be an example of how we might think, everyday way we might think of a line? I'm thinking like maybe a really, really, really long ruler. So I think of a ruler as kind of being like a line. A roadway, a really long roadway. Let's kind of think of it as a line, but it's not perfectly thin. So any of those might be examples of a line. The edge of the desk here, right at the corner, could be an example of a line, but it doesn't go on forever. But that might be an example. What would be a non-example of a line? A circle? How about an undefined term that we talked about already? Point. Point's a non-example of a line because it doesn't go on infinitely in both directions. So either of those could be non-examples. You could think of other non-examples of your own. All right, so we're good with line. Doesn't have a definition, it's an undefined term. Okay, our next, let's see, I have a question for you here. So here's your question, true or false? And here, let me write it up so you can see it. Let me write it in yellow here. The question is, this is the proper name for line DQ. True or false? False? Who thinks it's false? Most of us who thinks it's true? Who doesn't know? Not sure? Okay. So those of us that said it's false, what's wrong here?
There's no arrows.
There are no arrows. We need the arrows to show that the line goes on forever in both directions. So this would be false. This is what we need. We need the arrows to show that it goes on in both directions. When on a quiz or a test or in the book, when it says name the line using proper notation, this is what it means with the 2 points in the arrow over the top. That's what it means by proper notation. We're using, so we always do it the same way every time, so that when we write this, we know that we're talking about line DQ and point D and point Q are on that line. We always know what that means. And we'll talk about what this thing is without the arrows in just a minute. All right. Our next undefined term. Oops. Our last of our undefined terms is a plane. So our term is a plane. Important factor characteristic, it's undefined. So it doesn't have a technical definition. Other important facts or characteristics. It extends infinitely in all directions along a flat surface. And it has no thickness. So we draw it as a parallelogram, and what that means is we draw a part of the plane because the plane is infinite. So this is our picture of a plane, and we say that points M, N, and O are on the plane or in the plane. And we name it by the 3 points in the plane that aren't on the same line. Our 3 points can't be on the same line. So I would call this plane M, N, O. Or, not so much in this book, but sometimes you'll see planes and they'll write a script letter in the corner and you could call it plane R. Yes?
So do you have to list the additional letters?
No. The only thing you have to be careful with is that they're not on the same line. What would be the problem if there are 3 points were on the same line?
It creates a line.
It creates a line, and does that create one plane? Here's a line. Let's imagine this line down the middle of our paper. I can rotate the plane. There's a different plane that contains that same line, a different plane that contains that same line, different plane that contains that same line. So the 3 points have to be on can't be on the same line to make sure we have one plane. An example, a physical example, the way we think of a plane is a wall. Even though a wall is an infinite in all directions, it's not perfectly thin. The whiteboard is a physical example of a plane. The surface of the screen here, physical example of a plane. Kind of the way we think of a plane. Just a big flat surface. Non-example, what would be a non-example of a plane? An airplane? That's kind of a play on words there. How about some other things we've talked about already? A point's not a plane. A line's not a plane, so those would be non-examples. Someone else, one of the earlier ones that we used was a circle. A circle's not a plane, because it doesn't go infinitely in all directions. So those would be non-examples of a plane. And this could be your picture. All right, we good with our 3 undefined terms? So the next 3 that we talk about will have definition. We'll have technical definition. These 3, it's important that we know that they're undefined, but it's important also for us to know their characteristics. And I think I have another question for you here. Let's name this plane. Oops, I need to be able to grab that thing. There we go. So let's name this plane. We'd say plane. Fun. So this is plane fun. And those points F, U, and N are in our plane or on our plane. And we could also call this plane NUF, plane UNF, plane FNU. We don't have to list them in a particular order. As long as they're not on the same line, we're okay. All right, we're good with planes. So this is the kind of thing that your homework's going to ask you to do. Name the plane. Name 3 points on the plane. Name the line. Name 2 points that are on the line. That kind of thing. All right. Our next terms. So we put these 2 together because they're kind of similar. So you're going to have 1 box for each of these. One is collinear and one is coplanar. The technical definition of collinear, all points on the same line. Yes, so this would go in one of your empty boxes. Collinear would go in an empty box and coplanar would go in an empty box. Collinear is one term, coplanar is another term. Coplanar is all points on the same plane. Co means together, plane means plane. Collinear, co means together, linear means on a line. These second pieces, any 2 points are collinear, that would be an important factor characteristic. Any 3 points are coplanar, important factor characteristic. Your picture for collinear, you're just thinking of points that are on a line. So all those points are collinear. For coplanar, you could draw yourself a plane. All of these points are coplanar. An example of collinear could be all the points on this one particular line on my screen. All of those points would be collinear. An example of coplanar would be all these points on my screen. All of those points are coplanar. They're in the same plane as the screen. What would be a non-example of collinear? How about the points on this blue line on the screen and this point over here. So here's one line along this blue line here. All of these points are collinear with each other, but they're not collinear with this point, because this point isn't on the same line as the others. A non-example of coplanar would be all of these points on the screen that I drew, and a point out here in the room. The points on the screen are coplanar, but they're not coplanar with this one point out in the room, because the one point out in the room is not on the same plane as all of these are. So that would be a non-example of coplanar. And you can come up with your own examples, non-examples, in your definition in your own words. But how do you think of collinear? How do you think of coplanar? All right, we have one more term to put on our sheet for today, and then we should have two blank squares that we'll fill in on block day, I think. So the last term that we're going to talk about today is a line segment. So the last definition we're going to do, we have a couple more things to talk about after this. So a line segment, or just a segment. So that would be your term. Your technical definition, part of a line that begins at one point and ends at another. The points at the end of our segment, so this would be in your important facts and characteristics. The points at the end of your segment are the endpoints. This would be your picture of your plane, of your segment or line segment. 2 points at the end, calling one point A and one point B. Those are the end points because they're at the end of the segment. And another important factor characteristic is we name them using the endpoints with a bar over the capital letters for their points. So there is how we name segment AB. So your picture, this would be your picture, segment AB. This is how we name it. This is how we would name a segment with proper notation, with a bar over the end. So that was what we named before when they said, is this the proper way to name this line? It was actually naming a segment. So what would be an example of a segment? Everyday way we think of a segment. Hockey stick. So not the part that curves, but the handle at least, right? My pencil, you can think of this, my pen as a segment, just piece of a line. The edge of this edge of the table right at the corner, one piece of it. So from here to here would be a segment. An example of a segment. Non-example of a segment. Circle is a non-example of a segment. Line is a non-example of a segment. A point is a non-example of a segment. A plane is a non-example of a segment. So anything that isn't just one piece of a line.
Example, segment AB.
I said my pen. Yeah, that would be an example of a segment. Starts at the eraser. A ruler, that would be a good example of a segment. Just a way to visualize it. All right, we good with segments? Yes. So we have two more terms that we'll put on our sheets on block day, I believe. But there's a couple more things that we need to talk about that don't go on your sheets. So we still have a little bit more to talk about. Postulates or axioms. So we have our terms. Thank you. We have our terms that we either defined or said are undefined terms, and we talk about how we think of them. What we want to do is put together some rules for how these things work. How do points, lines, and planes work? Well, those are our postulates. And just like with our terms, we have to start somewhere. So postulates or axioms are something that we accept as true. Without proof. So we have to start somewhere. So some things we can't prove. They just seem to make so much sense that we say, okay, we're just going to say, yes, those are true. So that's what we're going to talk about next is our postulates or axioms. Our postulates or axioms involve two things. What do you think we mean when we say two things intersect? Come together. And Fabian's doing this. So that's a perfect example of intersection. They're coming together. They touch. They meet. They cross. So that's how we think of intersect. Our math way of saying it is have points in common. So if you wanted to draw a picture of what we mean by intersect, I'm going to draw two lines here, and we'll talk more about this in just a second. So we're going to say those two lines intersect. They touch, they cross, they meet. They have points in common. The intersection are the points that they have in common. The other way would say the points they share. So the intersection of these two lines that intersect, the two lines intersect, the intersection is this point. So intersect means they meet. Intersection is where they meet. And our postulates, the first several postulates that we talk about have to do with intersections. All right, are we good with intersect and intersection? Okay. Our first postulate. We're going to accept this as true without proof. The book numbers the postulates. It'll say postulate 1.2.1. I'm not going to number them like that. We'll just talk about our postulates. The intersection of two lines is, what do we think the intersection of two lines is going to be based on that picture we just drew? Here's my intersection. What is that intersection? Where they meet? What kind of thing is it? Point. is a point. So we're going to say two lines meet in exactly one point. Not 3 points, not 1.5 points, exactly one infinitely small piece of space. So the intersection of two lines is a point. We're going to accept that as true. Our second postulate, second thing we're going to accept as true without proof. The intersection of two planes. Is, so let me draw two planes here, and these continue infinitely in all directions. So here's their intersection. And what kind of thing would that be if we extended it infinitely? What would that be? Someone said it. A line is a line. So I'd extend this. My planes extend infinitely in all directions. So that's going to be a line. So we think of the intersection of the wall and the front wall where the flag is, that corner. If we extended the two walls infinitely, that corner would be a line. And we're talking about just the bit where they touch together. All right, we're good on that postulate. Intersection of two planes is a line. We have two more. Through any 2 points is exactly one line. So if I have 2 points here, there's only one line that goes between those 2 points. I can't connect those 2 points. If they're infinitely tiny, they take up no space. I can't connect those 2 points with anything else other than this one line. And finally, our last one for today. Through any three non-collinear So what do we mean? What do we mean when we say non-collinear? Collinear means they're on the same line. Non-collinear would mean they are not on the same line, right? Non-collinear, non means not. And what did you say that was going to mean? They're coplanar. Through any three non-collinear points is exactly one plane. So if I have these 3 points, there's exactly one plane that contains all 3 of those points. And my way of thinking about this is that's why they make tripods with 3 legs. Because no matter how you arrange those 3 legs are always going to make a plane. So your tripod's not going to wobble. Now if you put something heavy on it, it could fall over, but it's not going to wobble. If you put four legs on a tripod, those 4 points aren't necessarily coplanar, and your table can wobble. But a tripod, because 3 points are always coplanar, is always going to be stable, because it ends where it touches the ground. Those points are always going to be coplanar. So that's my way of thinking about this postulate. A tripod. All right, so we have our terms. We have our beginnings of our terms. We'll have more terms. We'll have more postulates as we go on. These are the most important. These are the foundations. That everything we're going to build geometry from is going to start from these terms and these postulates. All right, our homework. So there you go. And a lot of these are, like I said, name 3 points on this plane. Name two points on this line. Name the line where these 2 planes intersect. So that's the kinds of problems that this homework involves.